Vector equation of a line. In this module, you will learn about vector equation of a line and to represent it in Cartesian form. A straight line is uniquely determined on a plane by its direction and a point on it. Vectors also determine direction, and hence we can use vectors to describe lines. Consider a line L in the space passing through a point A, and suppose it is parallel to vector B. Let R be any arbitrary point on the line L such that the position vector of this point R is vector R. Also suppose the position vector of point A be vector A. Since vector AR is parallel to vector B, it will be equal to lambda times vector B, where lambda is some scalar. Applying triangle law of vector addition to triangle OAR, we get vector OR minus vector OA is equal to vector AR, which is also equal to lambda times vector B. Thus, vector R minus vector A is equal to lambda times vector B, or you can say vector R is equal to vector A plus lambda times vector B. This equation represents vector equation of a line. Each vector in the space can be represented as a sum of vectors parallel to the three axes of rectangular coordinate system. If coordinates of point A are x1, y1, z1, and coordinates of point R are x, y, z, then vector A is equal to sum of vectors x1 I cap, y1 j cap, z1 k cap, and vector R is equal to xi cap plus yj cap plus zk cap. If A, B, C represent the direction ratios of the line, then vector parallel to it can be represented as the sum of vectors ai cap, bj cap and ck cap. Substituting these values in the equation, vector R minus vector A is equal to lambda times vector B. We get this equation. We can also use column form for vectors. This equation is satisfied if it is true for each coordinate. Thus, we get these three equations. Solving these equations for lambda and rearranging them for lambda, we get x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C as the Cartesian equation of the line in terms of x, y and z. In this module, you have learnt that vector equation of a line passing through a point whose position vector is a vector A and parallel to a given vector B is vector R is equal to vector A plus lambda times vector B, where vector R is a position vector of any arbitrary point on the line. Equation of a line through a point x1, y1, z1 and having direction ratios A, B and C. is x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C.